Okay. Two trains leave a city at the same time. One is traveling east and the other west. At the end of 9.5 hours, they are 1,292 miles apart. If the rate or the speed of the train traveling east is 8 miles per hour faster than the other train, find their rates. Okay? You are going to have a problem like this on your test. You are going to have a problem like this on your quiz. So you want to be sure that you practice this. The formula that we are probably most familiar with is rate equals distance divided by time. Rate equals distance divided by time, and rate is speed, and you'll be given this formula. A rate times time equals distance is the same formula, just rearranged, okay? The way that we get rate times time equals distance is by multiplying my top formula by t. Okay, so the formulas are the same. We are actually going to end up using this formula for this particular problem. Okay, so we really have to wrap our mind around what's happening in this problem. And the first time that you read it, you might not really get what's happening in this problem. So you have to go back and read it again, and you have to go back and pull out pieces of it. Now, the first thing that you might pull out when you read this problem is that the trains have traveled 1,292 miles. That's going to be important. We just don't know exactly where it's going to fit in. But that may be the only piece that you're able to pull out the first time that you read it. The next time that you read it, you may be able to pull out that they're traveling in opposite directions. So this is a key piece of information. One is traveling east and the other is traveling west. So if I am sitting here in Birmingham, Alabama, one of my trains is headed towards Atlanta. Okay? And one of my trains is headed towards Dallas. Okay? Now, that doesn't have any numbers or anything in it, but it does give me an idea of what's going on. At the end of 9.5 hours, they're 1,292 miles apart. So from that sentence, I'm able to get this distance. Okay? What's the total distance that the two trains have traveled? The distance. What distance have the two trains added together traveled?
1,000.
Good. So their distance together is 1,292 miles. That's their total distance. Okay? Now, this is probably the part that's the hardest to kind of put all together. If the rate of speed of the train traveling east is 8 miles per hour faster than the other train, okay? That might be the hard part to figure out. How can I represent 8 miles per hour faster? How can I represent just that little phrase, 8 miles per hour faster?
8.
8 what? What'd you say? It's okay. Would we multiply? Would we add? Would we divide? How can we represent 8 miles per hour faster? Okay. If we multiply, that would be 8 times faster. Okay? So if I tell you that a plane travels 8 times faster than a car, Okay, if our car goes 60 miles per hour and a plane goes 8 times faster than that, which is realistic, then our plane would travel 480 miles per hour. Okay? What I'm telling you is that one train travels 8 miles per hour faster. So if my car is traveling 60, what's the other one traveling? 68. So what did you do with that 8? Added. So 8 miles per hour faster can be represented as plus 8. Now, is the eastbound train going the plus 8 or the westbound train? East. And so that's Atlanta. So my Atlanta is going to have something to do with plus 8. Okay? Now, what we want to find is their rates. We want to find their rates. And rate is the same thing as speed. Do you have a question?
I was going to ask, would we represent, in a formula, would we represent to solve the rate, would we represent it as X?
You certainly could represent it as X. Because of the formula, I'm going to represent it as R, but it would be fine. You are correct that our rate is our unknown. So representing it by an R or an X is completely fine. So you are correct. So how can I represent the speed of my train that's westbound or heading towards Dallas? Can I give, what?
-8.
Okay. Because I'm representing the eastbound train as plus 8, if I were to represent the other one as -8, there would be 16 miles per hour difference. Okay? And we don't want 16 miles per hour difference. We want 8 miles per hour difference. So if I represent the speed of the train headed towards Dallas as R, I can represent the speed of the train headed towards Atlanta or eastbound as R plus 8. Okay? That's the relationship. And sometimes it's that part right there that's the difficult part for us to get. Okay? And once we get the R and the R plus 8, we still have a little tweaking to do, but sometimes that's the super difficult part. Okay? So, I still have this 9.5 hours that I haven't dealt with yet. Okay, I haven't dealt with this 9.5 hours. At the end of 9.5 hours, they are 1,292 miles apart. So it says that they left at the same time. So how long has each train traveled? 9.5 hours. So my train towards Atlanta has traveled 9.5 hours, and my train towards Dallas has traveled 9.5 hours. Here I've got rate, and if I multiply that rate times time, I'm going to get the distance that that train has traveled. So if I multiply the train that's going towards Dallas times 9.5 hours, I'm going to get the total distance that that train has traveled. So I am going to multiply both of their rates times 9.5 hours. And let me tell you why that's true. You guys know that my daughter is in school in Huntsville. So we travel north on 65 to go see Madison. If I travel north on 65 at 60 miles per hour for 2 hours, how far have I traveled? 120 miles. So when I multiply my speed times my time, I get my distance. Okay? So when I multiply the speed of my train going towards Dallas times the amount of time it's been traveling, I get the distance that that train has traveled. Okay? So I have the distance of my east. Dallas is west, so I'm going to put west here. I have the distance of my westbound train. Then I also have the distance of my eastbound train. And what is the distance of the two of those added together? 1,292. Okay? Now, how can I represent in a formula or an expression the distance that my westbound train is traveling? Have we already figured that out? How do I represent it using R and the time? R times 9.5. Okay? How do I represent the distance of my eastbound train? R plus 8 times 9.5. Okay? Now, I'm going to let you solve this equation in just a second, but I want to rewrite it a little bit before I do. Okay? 9.5 is a mixed number. In general, I want you to leave fractions as fractions. I don't want you to turn 9.5 into a decimal. And the reason is when you deal with 1/3 or 2/3, the decimals get very messy. If you changed 9.5 to 9.5, you would be okay. It's the halves are not as messy. But in general, I want you working with fractions over decimals. Okay, so the first thing that I'm going to do is I'm going to take this 9.5 and I'm going to turn it into 19 over 2. And I got that by saying 2 times 9 is 18 plus 1 is 19. Then I am multiplying that times R. So I have just rewritten that. Okay? I am adding that to 19 over 2 times R plus 8. That is equal to 1,292. Okay? Now I'm going to give you 1 minute to solve this, but who can tell me what my first step would be in solving this? You're correct. There's something that I could do before that makes the problem easier to manage.
Simplify the fractions.
We can't simplify the fractions, but can I multiply everything by the LCD? What's the LCD? 2. Okay? So I want you to multiply everything by 2. So I'm multiplying this by 2, and I'm multiplying this by 2. And then I'm multiplying this by 2. Don't multiply this R plus 8 because that's already being multiplied by 19 over 2. You're just going to multiply 19 over 2 times 2 over 1. Then you're going to distribute what's left. So I'm going to give you 1 minute to do that, and then we'll talk about it. Here in the right-hand corner, I have rewritten this with my 2 times my 2 times everything here. My 2's cancel. So on my first expression, I'm left with 19R. We talked a lot when we were dealing with decimals about what happens when we've got something on the outside of a parenthesis that we need to get the decimal eliminated. And we talked about how if we do 2 times 3 times 4, once we multiply the 2 times the 3 and get 6, we don't deal with that 2 and the 3 anymore, correct? So here, once I cancel this, I don't deal with the 2 anymore. I'm dealing with the 19. So I have to distribute the 19 to the R plus 8. Okay? When I multiply 1,292 times 2, what do I get? When I multiply 2 times 1,292, that's this step right here. I'm multiplying 2 times this number. What did you get? Good, 2,584. Okay? Now, I distribute and I solve. So I have 19R plus 19R plus, what's 19 times 8? 152. And that equals 2584. Okay? So I have 38R plus 152 equals 2584. I subtract 152 from both sides. I get 38R. When I subtract 2584 and 152, what do I get?
2432.
Good, 2432. Now, I'm going to do that subtraction. I have 2,584 minus 152. 4 minus 2 is 2. 8 minus 5 is 3. 5 minus 1 is 4. And then 2, I bring my 2 down. Now, this step right here is where I divide by 38. That is probably a little bit outside what I will ask you to do without a calculator. Okay? It certainly can be done without a calculator, and we're going to do it without a calculator. And I certainly would practice homework when you're dividing 2432 divided by 38 without a calculator. I'm probably going to stick to 12 or 15, 20 or 30. I'm probably not, I definitely am not going to give you a number like 38 that you have to divide by. Okay? I definitely would expect to need to divide by 12 and even potentially 15. But I do recognize that 38 is kind of pushing it. So, but practicing how to do this is beneficial to you. Also, dividing by like a 20 or a 30 or a 40, that's kind of a reasonable thing because you just kind of mark out the zeros. Anyway, back to this one right here. I have 2432 in my box. And I put 38 on the outside of my box. So in order to do this division, I think to myself, okay, 38 is pretty close to 40. It's pretty close to 40. So I'm going to say, does 40 go into 2? Does 40 go into 24? Does 40 go into 243? Yes. About how many times? 6. Okay? 6 times 8 is 48. 6 times 3 is 18. Plus 4 is 22. Okay? So I'm going to have to do some borrowing. 13 minus 8 is 5. 3 minus 2 is 1. So then I'm left with 152. 40 goes into 152 about 4 times. Now, it's reasonable to say 3. Okay, the answer actually is going to be 4. If you put 3 right there and you multiplied it out and then subtracted, you would find that you've got an extra 38. So when you compared the remainder to what you're dividing by, you would realize that you've got to up that number once. So the answer to this is 64. 4 times 8 is 32. 4 times 3 is 12, plus 3 is 15. Okay? So R is 64. R, what does that mean? What does 64 mean? Okay? 64 is the rate. And are we talking about inches? Are we talking about the rate of speed? And what units are we talking about? Miles per hour. Okay? So R is 64 miles per hour. But what did R represent? The train headed to Atlanta that was going east, or the train headed to Dallas that was going west? It represented the train to Dallas. So this is my westbound train. So if my westbound train is going 64 miles per hour, what's my eastbound train going? 72. Okay? So the question that I'm being asked is, if the rate of the train traveling east is 8 miles per hour faster than the other train, find their rates. And have I done that? Yes, I have found their rates. Okay? Okay. Definitely be sure that you're comfortable with this problem. You're going to want to practice it. You're going to see one on Friday. You'll see one on your practice test. So we've got options. Okay? Now, let's go to the next one. I'm going to give you about 1 minute to write this one down. It's not as long. So I call this one my Kohl's problem. Does anybody shop at Kohl's? Okay. When you go to Kohl's to shop, what do you always have in your hand? Oh, Kohl's Cash. I forgot about Kohl's Cash. What else might you have in your hand? What? Well, something I'm going to buy. Yes. Kohl's is famous for their 15% off, their 20% off, or their 30% off. And you get them in the mail, and you show up at Kohl's, and then you get 20% off your whole purchase. That's what Kohl's is kind of famous for. So if I went to Kohl's and I found an item and I paid $8 for that item, okay? And I told you that I had a 20% off coupon, and what I handed the cashier was $8, what was the original price of that item if I had a 20% off coupon? $10. Okay? If I bought a pair of shoes for $75 and I paid $75 and I had a 25% off coupon, how much was the original price of the shoes? If I paid $75 for the shoes and that price included a 25% off discount, how much? $100. Okay? So, what you've got to wrap your mind around here is this dress is how much it was paid for. Okay? That's where students make their mistake. Here it says Della bought a dress at a 20% discount for $57.60. What was the original price? So $57.60 is less than the original price. So my final answer has got to be what? Bigger than $57.60. So if I get anything that is smaller than $57.60, that is a red flag that I've made a mistake. Okay? That's a red flag that I've made a mistake. So what we're going to do here is we're going to figure out how much the dress was before the 20% discount. So, one of the things that students forget is that if there is a 20% discount, what percent did you pay for the dress? Good. Good. If there is a 20% discount, 80% of the dress was the cost. Okay? And subtracting that percentage from 100 is where students oftentimes make mistakes. So if I tell you that the discount was 20%, you immediately subtract that from 100, so you get the percent that you paid for, not the percent off. So this 20% was the percent off, and if it's 20% off, then it's 80% paid. Okay? Now, how do I represent 80% as a decimal? Good. Okay, 80% as a decimal is 0.80. Okay, 0.80. That's the percent represented as a decimal. Now, could I even write it as 0.8?
Yes.
Yes. Okay, so that's going to be the same thing. So, I paid 80% of the original price. And when I paid 80% of the original price, what did that equal? 57.60. Okay? So, what operation is of in math? Like when somebody says 1/2 of 100, it's not division. Multiplication. So anytime you've got that of, you know you're going to multiply. Do we know what our original price is? Do we know what original price is yet? That's our unknown. So my formula for this is 0.8 times my original price, which I do not know, equals $57.60. So now what I need to do is I need to divide by this decimal. And that is something that you're going to be asked to do, is to divide right here. Okay, so I have x equals 57.60 divided by 0.8. So let's go off to the side and do that division so that you can remember how to do that division. Inside the box, I'm going to have 57.60 inside the box. The outside of the box, I'm going to have the 0.8. I'm going to have that on the outside. Now, I need to get rid of that 0.8 that I'm dividing by. So I am going to move that decimal one spot over. If I move it one spot over, what do I have to do to the 5760? Move it over. Okay? So I now have 8 being divided into 576.0. That decimal gets moved straight up in my division box. Okay? 8 goes into 57 how many times? 6. 7? How many? 7 or 6? 7. My mistake. 7 times 8 is what? Good. Okay, I subtract and I'm left with 16. 8 goes into 16. Okay. Bring down the 0. Okay, be sure you've moved that decimal up so you don't put $720. So my X equals 72. And we are talking about money, so that is $72. Now, checking this would be reasonable. It's reasonable to check this. Okay? A couple of ways that you could check it is you could say 0.8 times 72. So you could do that. You could also do 0.2 times 72, but when you multiply 0.2 times 72, you're getting the amount off. You're getting the amount saved. You know how we go to Kohl's and it says you saved $200? Okay? When you multiply by 0.2, you're getting the amount off. So then you would need to subtract that from 72 to get your 5760. Okay? So you can check that a couple of different ways. But the final answer to this is $72. $72. So some red flags for this one is be sure you know exactly what you're looking for. Be sure you know exactly what you're looking for. Okay? And in this one, we were looking for the original price. The original price. Okay? Let's do, I think, a rectangle. Yep. Okay. I'm going to give you probably 2 minutes to write this one down just because it's a little longer. Here we go. Suppose the length of a rectangle is 2 meters less than 4 times its width. So we know we're going to have to deal with that in a minute. okay? We may not be ready to deal with it the first time we read it, but we're going to have to deal with all that. The perimeter of the rectangle is 56 meters. Find the length and width of the rectangle. Okay? Now, I might not know where to start, but what kind of shape am I dealing with? A rectangle. So what might be the reasonable thing for me to do first? Draw a rectangle. Okay? So here is my rectangle. Okay? Typically, you've got a length of a rectangle and you've got a width of a rectangle. And I'm going to write those the other way. Okay? We've got the length of the rectangle and the width of the rectangle. And it really doesn't matter which one you label as which, but our width is going to be smaller. Okay? Now, the next thing that we probably need to do is we probably need to remind ourselves what perimeter means. So the things that students get confused are perimeter and area. Perimeter and area. Okay? Perimeter is the distance around the shape. It's like putting a fence up right here. Or it's the baseboard at the bottom of the room, in this room. Okay, that's the perimeter. The area would be all the grass that's inside this. Or the carpet, if this was a room. Or the tile that's in here. Okay? That's the area. So perimeter, we just add up the different sides is what we do. We add up the different sides. So what we're going to do now is we're going to remind ourselves what the equation or the formula is for perimeter. Does anybody know what it is?
2L plus 2W.
You got it. 2L plus 2W. That's the perimeter. 2L plus 2W. Now, if you couldn't remember that, would it have been okay for you to be like, well, I know I got to add W and W together, and then I need to add L plus L. I've got to add up the four sides. So would it have been okay to write it like that? Yes, because you would have gotten to 2L plus 2W. Yes, ma'am? It's not okay?
No, never mind.
Oh, I gotcha. I'm sorry. Okay, so as you kind of think about what perimeter is, it's okay if you kind of got to think through a couple of things. Now we've got to deal with this 2 meters less and our 4 times. Okay, how do I represent 4 times its width? How do I represent that? So I'm only focusing on 4 times its width. 4W. Okay? How do I represent 2 meters less than? How would I represent 2 meters less than?
2 minus 4W.
Okay, now, if I tell you that I have a 17-year-old daughter and my son is 2 years less than her, how old is my son? 15. So I have to do 17 minus 2. Okay? The 2 meters less than is represented by minus 2, but I'm subtracting it from the 4W. So the length of my rectangle is 4W minus 2. Okay? And sometimes we do get confused with what we're subtracting. Okay? Now, we know that we're using P equals 2L plus 2W. Do I know what the perimeter is of this rectangle? What is it? 56. So I can say 56 equals 2. What does my L equal?
4W minus 2.
Excellent. 4W minus 2. And then I am adding that to 2W. Okay? So now I have 2 times 4W, which is 8W. 4 times negative 2 is minus 4, plus 2W. 56 equals 10W minus 4. I add 4 to both sides. I get 60 equals 10W. What is W? Good. So W is 6. So I'm going to put 6 right here. How do I find the length? If my width is 6 meters, how do I find the length? Plug it in. So I'm going to do 4 times 6 minus 2. What's 4 times 6? Minus 2. 22. Okay? Now, can I check this? How could I check it if I wanted to? Okay, I could plug it into my equation. Okay, what I would encourage you to do is go all the way up here and plug it in. Okay, so I would do 56 equals 2 times 22 plus 2 times 6. 2 times 22 is 44 plus 12. And we have 56 equals 56. Okay? Okay. One more. And we can all relate to this one. I'm going to give you 1 minute just because of time to write this one down. To Rex. We can all relate to Rex. Rex has scores of 85, 92, 87, 88, and 91 on the first 5 exams. Okay? What score must he get on the 6th exam to have a 90 or better for all 6 exams? Okay. So the first thing that I want to talk about is the scores that Rex has. So if I wanted to know Rex's average right now, I'm not talking about his average after the exam. I'm talking about his average right now. What would I do? Good. I would add them all together. So I've got 85 plus 92 plus 87 plus 88 plus 91, and I would divide by what? 5. Why 5? Okay, that's how many exams he's taken, and I want to know what his average is right now, and that's how I would do it. Okay? Now, he's got one more exam to take. Does he know what he made on that exam that he hasn't taken yet? No. How do I represent an unknown? Plus X. When I do plus X, I'm no longer dividing by 5 exams. What am I dividing by? 6 exams. Okay? So I am adding all my exams together, adding an unknown, because I don't know what that is yet, and then dividing by the total number. And the total number is 6, because we've got to count that 6th exam that we don't know. Now, think to what we did on Monday and think about how you would represent a 90 or better. Okay? Would it be okay if it equaled 90? Yes, because that's an A. It sounds like he wants an A. But would he be happy with something greater than a 90? How do I write that? Greater than or equal to. Okay? Now we know how to solve this. Okay? And we're running out of time. 85 plus 92 plus 87 plus 88 plus 91. When I add those together, I get 443. Okay? I still have my plus x right there because I don't know what that is. And once I know what x is, what am I going to divide by? Good. And that's greater than or equal to 90. Now, this is an equation that I know how to solve. So what I'm going to do now is I am going to multiply both sides by 6. What happens right there? It's canceled. So I am going to have 443 plus x is greater than or equal to 540. Okay? So now I subtract 443 from both sides. And I get x has got to be greater than or equal to a 97. Okay? Your answer to this is not x equals 97. Your answer is a 97 or higher. Okay? Your answer is that it's got to be 97 or higher. So if you leave it as x is greater than or equal to 97, you're fine. But if you write x is equal to 97, then that's not the whole thing. Okay, you have